Lastly, let us use mesh current analysis to determine the voltage drop across our 3 ohm resistor as measured by our voltmeter. We will do such by constructing n minus n sub c KVL loops. By doing this, we recognize that we have I1 opposing our 3/4 of an amp current source, whereas I2 runs around our 4 ohm, 3 ohm, 2 ohm resistor and 9 volt source. That is, we only need one KVL equation for I sub 1 is specified. Step 2 is to assign our voltage potentials consistent with our passive sign convention. Starting with mesh 1, we have V1 corresponding to our 4 ohm resistor. As we proceed with mesh 2, we have V2 corresponding with our 3 ohm resistor and V3 corresponding to our 2 ohm resistor. We do not doubly identify V1 across our 4 ohm resistor. Step 3 is to construct n minus n sub c KVL equations. We will apply this to mesh 2. In doing such, we'd have minus V1 plus 9 volts plus V2 plus V3 is equal to 0. Step 4 is to apply Ohm's law to express our voltage potentials in terms of our mesh currents and our resistances, where V1 is expressed as I1 minus I2 times 4 ohms. Therefore, we'd have minus the quantity I1 minus I2 times 4 ohms plus 9 volts plus V2 plus V3, which is expressed as I2 times the quantity 3 plus 2 ohms, or a total of 5 ohms. Now we have one current source equation. I1 is equal to minus 0.75 amps. Therefore, we can substitute this in to our KVL equation and solve for I2, where I2 is equal to minus 1.3 repeating amps, which then when we solve for a voltage drop across our 3 ohm resistor, V2, which is equal to I2 times 3 ohms, we have a value of minus 4 volts.